Hi, I'm Chrissy O'Malley, and this is Better Science Teaching. What I'd like to talk about today is a long-range plan for a science fair project. Right now, it's June. It's just the beginning of summer break here in the United States, and my school science fair happens in the middle of February. So that's the kind of target we're looking at. 8 months is a great amount of time for a science fair project. When I was a student, I unfortunately had the habit of, let's say, procrastinating until very close to our science fair, and spending lots of nights up late working on things, not getting any sleep for days in a row, and it was kind of terrible. I don't like having my students do that, and I want to help you be better at that too. So we're going to talk about some of the major milestones we're going to hit so that we can make sure that we stay on track to finish this in the right amount of time without having to have many sleepless nights. Our goal is, even though we might have to work on our project for a couple hours at a time, that nobody loses too much sleep in the way that makes you not functional the next day. So first, with my students, you're going to have a Google form to fill out, and that's something that gives me a little bit of information about what your intent for this project is, why you chose to take a class that has science fair as a required component, and what your goals are. Because if you have goals that are very ambitious, things like, I want to present at ISEF, I want to win lots of awards at the State Science Day, then we're going to approach your project a little bit differently than somebody who says, you know what, I wanted to take an honor science class, I don't really care about science fair, I just want to do the school one and be done with it. That's fine too. You can choose that. But if you're going to put the work into the project, you might as well reap some of the benefits too. So that's going to be the first task for my students. The next thing that's going to happen is, by the end of June, I want my students to come up with some good novel ideas. So I'll have another video about how to come up with good ideas. But we're going to target the end of June at having a direction so that everybody kind of already knows what direction you're going to head with your project. If we know that early in the summer, that gives us lots of time to figure out exactly which direction we're going to go with that. For my students, their final project should be targeted around the end of July. So that's a whole 2 months from now to come up with a project idea. No problem. I'm going to be helping you with that every step of the way. We have no problems with that. The next step is going to be that by the middle of August, which really is kind of focused on the beginning of school, the next thing is our annotated bibliography. By the first week of school, my students are going to come in and have an annotated bibliography of at least 6 peer-reviewed references where they've identified projects that are somehow related to what they want to pursue, and they've been able to analyze them for content. And what we're looking for in the annotated bibliography is that you understand a summary of the work, you understand the statistics and the data that was involved, and you understand how it can contribute to your project. That basically is the information that we're going to use to turn it into a literature review by the end of September. And so a lot of teachers will call this your introduction. So if you're writing an introduction for your science fair paper, what you need to do is write basically a short essay about the related work to your project that's already been done. If you're doing your literature review and you realize, oh no, someone's already done my experiment, you need to come up with a way to make it a little bit special, because otherwise what you're really doing is a demonstration, and that's not really what the idea of science fair is. After our literature review at the end of September, the next thing is developing a research plan. This is designing the experiment that you're going to carry out and telling us how you're going to collect data and how you're going to test a hypothesis. That's going to be due by about the middle or end of November. The reason that I do that from my classroom is because that sets us up to be able to start experimentation by Thanksgiving break. It's really the first big chunk of time that students get in the fall that's not completely obstructed by sports and dances and musicals and plays and all the other extracurricular stuff that's going on. And so Thanksgiving is a great time for students to be able to kind of start that. The caveats to that: if you have students that are going to be doing any of these things, human subjects, animals, plants, microbes, chemicals, or potentially hazardous biological agents, you need to know that ahead of time. So for my students, that's going to show up in that Google form. Are you even thinking about these things? Because there's 2 complications. Well, there's 3. One is We have to pay attention to ISEF rules and make sure that students are following appropriate ethics, particularly in the use of vertebrates, so humans and vertebrate animals. They're not doing anything that's totally crazy with DNA or doing something that's hazardous to the environment around them. With plants tend to be kind of innocuous, but they don't grow that fast. So if you want to do a plants project, you have to kind of think about when your plants want to be growing. So if you want to do your plants project outside, be in touch with your teacher ahead of time, so that you can make sure that you are following all of the rules and you get all of your appropriate pre-approvals before that point. So by Thanksgiving, we're going to be at the point where we can do experimentation, and this is going to feel pretty comfortable to us. We're going to be like, I got no problem. I get 3 months till science fair. I'm already set up for my experiments. No big deal. Okay, so then we have December to do our experimentation. It's a great idea to work on that just a little bit at a time. If you have an experiment, you decide you want to just carve out a weekend and knock out your experiment because you're doing something that's physical science. You can. That's fine too. No problem. Just make sure that you're recording all of your data and that the data that you're recording actually answers the question that you set out to answer. The first week of January is when my students come back to me with data and with charts and graphs. And the way that that looks in my classroom, guys, is that will be a time when students can come in and they will bring their drafts, they will bring their logbooks with their data, and they will bring their graphs in, and we all kind of swap them with each other. And students will write their question and their hypothesis at the top of their first page, and then they'll do peer review. And the point of that is to discuss if the data and the charts that were presented actually answer the question and say something about that hypothesis. If not, we may need to do some revising, either in terms of the way the experiment was handled and maybe some follow-up experimentation, or think through if we worded our question in a way that actually poses the question that we tested with our experiment. So that's a good point of reflection for that. That happens in January. Now we're just a couple of weeks out from our science fair. So keep in mind where we're at. We already did our introduction, our literature review. We wrote up our experiment when we did our experimental design following our ISEF rules. We have carried out our experiment. We've made our charts and graphs. We're doing pretty well. So the end of January, the beginning of February is where we'll assemble our paper. So we'll have a research paper to put together. For my classroom, that will be an APA style because that's what scientists use. I also generally follow the Ohio Academy of Science publication guidelines. The reason that I do that is because for my students then when they go out to a science fair with their paper, they have something that's actually in a publishable format. They could choose to submit it to the Ohio Academy of Science if they wanted to, right out of the box. So our final paper gets put together at the end of January, early February. That gives us 2 weeks to figure out our presentation, which we do talk about quite a bit in class and how to do an effective presentation with science. But that means that the only part of the assignment that you have left for the 2 weeks before the fair is put your board together. And what does that mean? It means taking all that stuff that you already wrote, your introduction, your question, your hypothesis, it's all part of your introduction, your experimental design that you wrote up in November, that needs to get put up on your board. Your charts and your graphs that you made, those get put up on your board. So really all that we're doing is distilling down that information and putting it into a visually interesting, but also extremely easy to digest presentation that you can take and share with other scientists. And the oral presentations, I think, are kind of the real moment of payoff. I know that that's the thing that gives a lot of students a lot of anxiety, is standing up in front of a professional scientist or an engineer and talking about what you did. But that's the moment that to me is really exciting, because as a teacher, I want to help students understand what science is and how we share scientific ideas and meet other people that can encourage students in that. And so that's really the real payoff at the end. So I hope this helped you to plan your science fair project, and I'll talk to you soon. Stay safe and be well. Bye.